This video is for section 4-1, Positive Integral Exponents. We're beginning chapter 4 about polynomials and factoring. Which of the following do you remember how to do from Algebra 1? 7 squared minus 7 to the third. Pause the video for a couple seconds for you to write down what you think the answer is. At least take a guess on that. And the answer is 7 to the fifth power. And here's the reason. Because 7 squared means 7 times 7. And 7 to the third means 7 times 7 times 7. There are 5 7s being multiplied together, so 7 to the fifth power. Next, try this second one. I'll pause the video for you. This time the answer is 16a to the fourth power. And here's the reason. 2a to the fourth means 2a times 2a times 2a times 2a. The 2 times 2 times 2 times 2 portion is 2 to the fourth, or 16, and there are 4 a's being multiplied together. Try the third one. I'll pause the video for you. At least take a guess. This time the answer is 7 to the sixth power. And here's the reason. Because 7 squared raised to the third means 7 squared times 7 squared times 7 squared. In total, there are 6 7s being multiplied together. Try this fourth one. This time the answer is 5 to the fourth power, or the actual number 5 to the fourth power. Here's the reason. 5 to the 7 means 5 times 5 times 5 times 5 times 5 times 5 times 5. 7 5s being multiplied together in the numerator. In the denominator, 5 to the third power is 5 times 5 times 5. Then some reducing happens. What's left over are 4 5s being multiplied together. Try this next one. This time the answer is 5 to the negative 4 power, or better, 1 over 5 to the fourth. The reason is similar to the expansion we did in the previous problem, but this time the 3 5s are in the top and the 7 5s are in the bottom, so after the reducing happens, the leftover 5s are in the bottom. Finally, try this last one. I'll pause the video for you. And the answer is a to the fourth power over 16. Here's the reason. A over 2 to the fourth power means a over 2 times a over 2 times a over 2 times a over 2. When multiplying these together, there are 4 a's being multiplied in the top, and in the bottom, 2 to the fourth power, which is 16. In Algebra 1 class, these were called the exponent rules, or properties of exponents. These involved patterns that it was helpful to memorize. So when you had a problem like the first one, you could quickly add the exponents, getting an exponent of 5. Or when you had a problem like this third one, you could quickly multiply the exponents, getting an exponent of 6. Or like the fourth one, you could quickly subtract the exponents, getting the exponent of 4. Here are the exponent laws that were illustrated by those 6 example expressions. In these laws, the a and b are any real numbers, except that b is not 0 whenever it's in a denominator, and the letters m and n are integer exponents. Law number 1, when multiplying powers that have the same base, you can add the exponents. Law number 2, when multiplying two things together and then raising to a power, you can separately raise each factor to the power. Law number 3, when taking a power and raising to an exponent, you can multiply the exponents. Law number 4, to divide powers, you can subtract the exponents. Rule number 5 is also about dividing powers, but if the exponent in the denominator is greater than the exponent in the numerator, then your answer will be 1 over a power. And rule number 6 is about raising a fraction to an exponent. You can raise the numerator to the exponent and the denominator to the exponent. Algebra will be a lot easier if you recognize these patterns when you have them in an expression. Let's try some examples. Simplify this multiplication problem. Start with the numerical coefficient. 2 times negative 2. That's negative 4. Then, when working with the variables, apply the appropriate exponent laws. T to the first power times t to the third is t to the what? It's to the fourth, because when you multiply variables, you add the exponents. Now let's work with the letter k. K to the second times k to the fourth is k to what power? It's to the sixth power, because when you multiply letters, you add the exponents. Next example, negative 5x raised to the third power. Start with the numerical coefficient, negative 5, and raise it to the third power. Negative 5 times negative 5 times negative 5 is negative 125. Then raise the letter to the power. The next example is very similar. It also has a product being raised to a power, so follow the same exponent law. Start with the numerical coefficient, negative 3, and raise it to the fourth power. So negative 3 times negative 3 times negative 3 times negative 3 is 81. Then work with the variable. P to the second raised to the fourth is p to the eighth, because when you raise a power to a power, you multiply the exponents. Then the letter Q, what exponent goes here? It's a 20. A few more examples, this time with division. Simplify these and identify any domain restrictions. Well, before we start, I notice there's a blank spot. This should have the letter X in it. Start with the coefficients. 24 divided by negative 6 is negative 4. Then work with the variables using the exponent laws. X squared divided by x squared cancels away. Now the letter y. Y to the fifth divided by y to the third makes y to the, what goes here? It's a 2, because when you divide variables, you subtract the exponents. 5 subtract 3. Next example, start with the numbers. Negative 5 divided by negative 25 makes positive 1/5. Now let's work with the variables. T to the eighth divided by t to the fifth is t to the third. Now the letter K. When you divide letters, you subtract the exponents. Because the exponent in the denominator is greater than the exponent in the numerator, the remaining letters are in the denominator, k to the 2. Final example, we have a fraction being raised to a power. Let's follow the exponent law. You raise each factor in that fraction to that exponent. Start with the number 2. 2 to the third power. That's 8. Then the letter Z. Now in the denominator, what is c to the third raised to the third? That's c to the ninth. The problem also said, identify domain restrictions. What numbers can't you use for the variable? In the first example, what variables are in the denominator? It's x and y. Remember that you can't have 0 in the denominator of a fraction? So the restrictions are that x cannot be 0 and y cannot be 0. In the next example, what variables are in the denominator? T and k. So the restriction is that t cannot be 0 and k cannot be 0. In the last one, what variable's in the denominator? So what's the restriction? C cannot be 0. Let's summarize the lesson. We reviewed the exponent laws that you learned in middle school math and in Algebra 1. When do you add exponents, or when do you multiply exponents, or when do you subtract them? And we used those laws to simplify expressions.